Welcome everybody to our webinar session. We are very excited about having you today. We will start soon, but first we will mention some points related to the organization. Your microphones is on mute. We will keep this feature as it is to provide an organized session to avoid background noise and interruptions during the presentation. However, we have a messenger option. In the bottom of the screen, you will see an icon. You can submit written questions by typing them in the question box in your control panel. We would like to have an interactive session and discussion, so please feel free to send your questions. You may send them at any time, and we will collect and address them at the end of this presentation. You will be able to count with the presentation that will be shown during the conference. It will be sent by email on PDF right afterwards. Now I would like to introduce our speaker. Mr. Michael Graveman is a recycling equipment professional representing Granutech-Saturn Systems, a world leader company in size reduction equipment. After attending the University of Kansas, Mike began working in the recycling industry in 2005, working first at Magnatech Engineering and continuing with Granutech-Saturn Systems in 2014. Mike enjoys his time working in the recycling industry because of the variety and constant change in market conditions, material specifications, and customer needs. These changing needs in the industry have inspired Mike to be involved with numerous new product developments during his career. He believes that the only thing that remains constant in the recycling industry is that recycling professionals will always expect superior performance, quality, and product support from their equipment suppliers. About the company, founded in 1968, the global company that is today Granutech-Saturn Systems is a leader in recycling equipment design, quality, and innovation, and based in Dallas, Texas. Its world-class product offering includes Saturn shredders, grinders, granulators, and refiner mills. The company's success in the marketplace is a result of continuous investment in fabrication and automation integration capabilities. These capabilities can be utilized on single machines or complete tire recycling system. Granutech staff has an average of 18 years in the industry, and the company has been a leading industrial recycling manufacturer for more than 5 decades. About Weibold Consulting, the company was founded in 1999. Over the years, Weibold gathered an international team of experts and established a large professional network involving researchers, decision makers, and authorities. Today, Weibold maintains liaison with many industry players, including world's leading innovators. This enables Weibold to receive first-hand information about markets, new products, and innovative technologies in the field of tire recycling and tire pyrolysis. In addition, Weibold issues a free monthly newsletter on tire recycling and pyrolysis, which relates to all aspects of these industries and provide unique takes on the newest developments and trends. We hope you enjoyed this session. Mike, please, whenever you want.
Thank you, Augustina. I'm here today to talk about reliability and profitability in tire recycling and how it all starts with quality equipment. It starts with quality equipment, but as we all know, it doesn't end with quality equipment. First, I'd like to thank you, Augustina, and Weibold for the invitation to be here today. As Augustina said, my name is Michael Graveman, and I'm with Granutech-Saturn Systems. I'm a regional sales manager with Granutech. First, I'll tell you a little bit about our company. Granutech-Saturn Systems is a leading recycling equipment manufacturer located in the Dallas-Fort Worth metro, which is in Texas in the southern United States. We've been in business since 1968. We're a manufacturer of the Mack crusher and baler equipment. We're a manufacturer of the Granutech tire recycling equipment, of Saturn 1, 2, and 4 shaft shredders, and also the manufacturing partner for 3Tech mobile hammer mills. So I'm here to talk to you today about tire recycling, but overall that's only a portion of the business we do. And we do have a worldwide network of sales agents and successful customer installations worldwide. On the left, you can see a aerial view of our facility. We have in the middle our manufacturing center, service, inventory, manufacturing, and all of the product and customer support happen here. And then on the left, you can see a building which is our machining center. And then in the rear, you can see our paint booth, our testing facility, and our outdoor storage area. In this webinar, I'll talk about 4 main points, and they're all a little bit related. Obviously, we talk about reliability and profitability, and I think most people understand that those two are really the same thing. But the 4 points that I'll address in this webinar are 1, what are the parts of a tire recycling plant? Where to start when shopping for tire recycling equipment? Why is it so important? What size crumb is required? And how to tell whether a tire plant is suitable for your needs. So first, I'll dive into what are the parts of a tire recycling system. Here at Granutech, we have 4 stages of equipment, and we call them stages generally because we have individual equipment that goes in each category, but we have multiple pieces of equipment that can do each task. So for instance, stage 1, we have a variety of different shredders that can accomplish stage 1 tasks, and in stage 2 we have a number of options for stage 2 tasks as well. But the important thing to recognize is that a stage 1 task, a primary shredding task, can't be done by a stage 2 machine and vice versa. So for a customer that needs stage 2, well, you need stage 2 and stage 1. And if you need stage 4, well, you need stage 4 and 3 and 2 and 1 also. So stage 1 is the primary shredding option. This is generally done with a dual shaft shredder. This is the part where we accept whole tires, truck tires, passenger car tires, whatever. And generally, we're going to be shredding this down to something that's roughly 50 by 500 millimeter in size. And the final size is going to depend, obviously, on where the material is going. An alternate daily cover, which would be used by a landfill or ADC, is going to be a much bigger size than like a tire-derived fuel, which is generally a clean 50 millimeter by 50 millimeter chip. If a customer needs smaller than stage 1 is capable of doing, we're going to move into stage 2, which is the grinding phase. And the grinding phase is generally going to take that chip from stage 1, and it's going to reduce it to something, if you're looking at your thumbnail, about the size of your thumbnail or maybe a little bit smaller. Material from the grinding phase can be used as a premium TDF product, where it has other commercial applications like landscape and playground material. The important thing that really happens in stage 2 is that the steel inside the tire is liberated from the rubber material. So after stage 2, I guess we can call it stage 2B, would be a magnetic separation. And at that point, you can have 2 different product streams, one of a wire product and then one of a quite clean rubber product, again, about the size of your thumbnail. Moving on from stage 2, we have stage 3, which is the granulation step. And I wrote 6 to 15 millimeters for the purposes of being inclusive, but generally this is more along the lines of a 6 to 10 millimeter product. Material from the stage 3 machinery can be used in some landscape and playground and equestrian purposes. And then from stage 3, we move on to stage 4, which is crumb rubber, which is generally 6 millimeters or smaller. And this is generally used in applications such as asphalt or turf applications. There's also some injection molding applications as well. So looking a little bit deeper into stage 1, we have primary shredding. This is typically done with a dual shaft shredder. I mentioned it's 50 to 500 millimeters in size. And material doesn't come out of the dual shaft shredder sized to, for instance, the 50 millimeter by 50 millimeter product. The cutters in the dual shaft shredder are approximately 50 millimeters wide, generally. So a lot of times the material will be 50 millimeters by 200 or 300 or 500 millimeters, and it falls out of the machine in that state. So we achieve smaller size through recirculation of this material. You can see in the picture on the right, we have one of our medium-sized shredders here. This is a dual shaft shredder that is feeding a classifier. And this classifier has a double deck on it. The deck you can't see, but it vibrates, and it has a bunch of holes that are presumably 50 millimeters by 50 millimeters. So as the material falls on here, the material will follow this deck all the way across, and unless it's small enough to fall through, it comes out the end onto the chute, and it goes back up this conveyor and back into the shredder, where it gets sized again. And it can keep doing this indefinitely, really, until the material is small enough that it can fall through this little opening here, and it can be conveyed off to another bin. So this would be used for making like a TDF product generally. In this middle picture here, I show a typical cutter for a dual shaft shredder. Actually, 2 cutters for 2 different machines. This is probably one of our larger dual shaft shredders right here, and this is probably one of our smaller ones right here. And then on the left, I show a sample of some of this material. This is going to be a whole tire material that is probably a double pass. It's probably been through a shredder twice. And this is not a TDF type material, but this is something that presumably would be passed on to a stage 2 machine. And of course, there's a couple different options to get there. Some stage 1 machinery doesn't have any recirculation if it's not needed. Some has just a double pass or different options for recirculation, including sizing. And as you can see here, some of it can even be made mobile. We have a 6240 right here with a conveyor, a disc screener, a recirculation loop, and then an in-feed conveyor right here. So this is a machine that could be taken to a facility and shredded like that. And then on the right, there is a better picture of one of our dual shaft shredders. So you can see the material, the tires will fall in here, and as those hooks on each shaft come together in the middle, they grab the material and pull it in between the shafts and reduce it by a shearing action. And you may have noticed I skipped OTR tires. OTR tires are kind of what I would consider a stage 0 machine. Generally, they can be shredded with a very, very large shredder, such as a 7272 XT OTR shredder. And this would take smaller or medium-sized OTR tires, or oftentimes they'll need to be segmented into smaller sizes still to be handled. But as you can see, this is just a very, very big dual shaft shredder, very similar to what the Stage 1 machinery looks like. But generally for a application like that is going to require a dedicated machine to handle any significant volume of OTR tires. Moving on to stage two. Stage two is the grinding stage. We have a couple options available depending on the volume and the size that we're making, but we do this with our Grizzly M80 or our Grizzly S80 grinders. These are medium speed grinders. They operate at approximately 300 RPM or 120 RPM. And they generally make a 15 to 25 millimeter product. As I mentioned earlier, this is the step where the material is liberated from the wire is liberated from the rubber. And what I mean by that is that when the material comes out of the machine, it's all commingled, obviously, but because it's liberated, you have pieces of wire and you have pieces of rubber, but they're no longer attached to each other. So after this machinery, you can take it to a magnetic separation, and you can make these materials or these product streams that you see down on the lower left. We have at the top right in this picture, we have a rubber with wire. So this is what the material is going to look like coming out of the machine. And then we have on the left a wire product. So if you took a magnet to this rubber with wire product, you would have wire that looks like this stuck to the magnet still. And then what you would have sitting on the piece of paper would still be your rubber material, which is shown down here at the bottom. So on the right, we show our Grizzly S80 right here, which is going to handle that pre-shredded material. And it's going to fall in the top and be sheared by this rotor. You can see this machine here still has very massive knives on it, which are needed because it's still processing all of this wire material, which is, as you can imagine, incredibly abrasive. So stage two machinery still has to be very, very durable to handle the wire material and the rubber material. And as this machine rotates, it's sheared against this stationary blade at the bottom, and there's a screen which you can't see that that provides the sizing. Anything larger comes back around and is sheared again until it eventually falls through the screen at the bottom. Stage three is typically done by a granulator or a grinder. We use our Grizzly M80 as a grinder. And generally this is going to make, as I said earlier, a product 6 to 15 millimeters in size. And this is really the first step in tire recycling where you're handling the rubber with no wire in it. But what really happens at this stage, at the granulation stage, is the fiber. There is, in passenger car tires, there's obviously a fair amount of fiber present. And really at this granulation stage, this is when the fiber begins to be released from that rubber, much like in stage two, the steel was released and liberated from the rubber. In stage three, this is really the step that begins a lot of that process of liberating the fiber. So fiber removal starts to become critically important and messy. I mean, really, it's important at all stages in a tire recycling plant, but stage three is probably the most critical part of handling that fiber. And then stage four is the crumb rubber phase. So stage four takes the product from stage three, and we process it with either a cracker mill like our G4X or our powderizer. And generally, this material is going to be something between 0.6 millimeter and 6 millimeter. Injections are for injection molding, for asphalt, and for other applications. And yes, there is still lots and lots of fiber that is released in stage 4. So on the left, you can see a picture of our powderizer. This is actually a relatively small machine that is very, very efficient and provides excellent sizing of material. So it's great for a very flexible requirement in creating the stage 4 sizes. And generally for higher volumes, it'll be put in parallel with other stage 4 machinery like other powderizers to achieve a higher volume. The inside of this machine looks very similar to just a small granulator. So it operates very much like stage 3, except that the chamber and the rotor are much smaller. On the right, you can see the G4X cracker mill, and this cracker mill operates by virtue of rotating these two shafts, which are operating at different speeds. And you can see the shafts have corrugation on them that allow the material to be sheared and cracked as it rotates through them. And you can imagine that because that material has a place to go inside those corrugations, that it doesn't affect 100% of the rubber inside the chamber at any given time. So when it falls out, you have some rubber which has been reduced in size, and you have some rubber which didn't get reduced in size at all. So looking at that in a little more detail, typically the cracker mill applications with the G4X require a classification and sizing system, much like you saw on stage 1, except obviously it's intended a little bit more for powder instead of large tire chips. So looking at the diagram on the right, you can see that there's a feed bin which would accept the material from the granulator, and that goes in through a screw conveyor to the G4X, which is typically water-cooled with a chiller. There's a series of discharge conveyors that take it over here into a screener, and the sized material from the screener will come out this discharge conveyor, and the oversized material will be on this return conveyor, which comes back to the G4X mill. So again, much like phase 1, you might have material that gets to make several trips around this rotation before it finally falls through the screener and comes out this discharge conveyor here. And then on the left, you can see the powderizer. This is a 4 powderizer installation. So we have 4 machines, which could be making all the same thing, or 4 different sizes, or different products. This is a very flexible arrangement. Also, because you can, for instance, do maintenance on one machine or repairs on one machine with a lockout, and you can still be operating the other 3. And then you can see here on the right and down below that, as I said earlier, the fiber separation is a constant process. And you can see that we're removing fiber at all of these locations from all 4 powderizers. And beyond the major components, the stage 4 components, which I think is what a lot of people think about when they're thinking about tire recycling, we really can't ignore the peripheral components. These peripheral components are probably every bit as important as the major components. They may seem relatively insignificant because it's just a screw conveyor, or it's just a belt conveyor, or it's just a screener. But at the end of the day, we know that to make a quality product, these peripheral components have to do their part of the process to convey the material, to keep the product clean, and to feed properly each of the steps of machinery that they're feeding. So these peripheral components would include a conveyor system. We use belts, screws, air conveyors. They would include magnets. We have drum magnets, belt magnets, plate magnets. There are screeners, density separators. Fiber separation, again, is a constant thing in these. And then finally, the packaging and what form of packaging you need. But at the end of the day, what we know is that quality is the result of hard work and attention to detail. And that is true with every component in the tire recycling plant. So one of the questions that we get a lot is where to start. Where do you start when you're trying to decide if you're getting into the business and if you're looking at a properly engineered system? So one of the first questions that you need to look at is do the feeding devices keep motor load constant? And by that I mean we'll take the stage 2 device, for instance, the Grizzly, which is generally fed with a tumbleback feeder. That tumbleback feeder is a metering device that provides a constant flow of material to that Grizzly. And what we want to see is we want to see that the motor load comes up to an appropriate loading for the motor and it stays there, and that we're not feeding big chunks of material, a big bundle of material that may fall off of the on the conveyor that can go into the machine, and it can either overamp the machine, requiring the feeding device to shut off, or in an extreme situation, it could even stall the machine, requiring it to be cleaned out. So those feeding devices are present to keep the motor load constant and to keep the machinery able to do its job consistently and efficiently and smoothly. We want to see that the material handling components are conveying the material without buildup on the conveyors or on the floor, without material loss, without spillage. We want to see that the fiber separation and the dust collection is effectively removing the fiber and conveying it out of the material. And then we want to see that the destoning and the gravity separation is removing the high density particles from the rubber product. And most importantly, does the output material look clean without any fiber or debris in it? So within a tire recycling facility, there's a number of different processes that we use. Starting at the top left, we have air systems to convey material. Sometimes these are used for cooling of stage 3 and stage 4 applications. We have metal separation, which you can see here is a belt magnet on a stage 2 Grizzly. And then you can see fiber separation, and which is happening here, and a destoner, which is happening down here, pulling out the higher density material like stones and sand. And then finally, over here on the left, you can see the packaging component, which is filling super sacks. So looking in depth at the material handling category, you have to ask, why do you use belt conveyors, which are used to move larger material or sometimes material with an elevated temperature? You use screw conveyors or elevators to move size material where you want to control dust, or you need to change elevation quickly, which helps keep the footprint of the plant much smaller as you're designing it. And then finally, there's pneumatic systems, which move material where the airflow assists the process machinery for cooling. But overall, you want to avoid using the air systems once the crumb is made very small due to the product losses. But one thing that's very important, we talk about quality with the machinery, but when it comes to quality and reliability, picking the machinery is really only the first step. The machinery has to be maintained properly, and there's really no place in a tire recycling facility to skip maintenance. More plant downtime actually occurs due to these peripheral components than to the primary machinery itself. So the takeaway from this is that all tire recycling facilities and all operators need to take as much care with even an inexpensive conveyor as you would with a shredder. Looking at the magnets, something that that a lot of people think is a magnet is a magnet is a magnet, right? You know, all magnets are the same, and of course, that's not true. There's a number of different magnets that are used in a tire recycling facility. We have belt magnets, which are typically the first stage of reduction, and the belt magnets will pull the material off of the first pass, and we'll get all the biggest products. And then from there, we would go on to a drum magnet, which is typically a stronger field and catches those smaller particles. And then finally, we use plate magnets, which can be used as a last resort in case of some type of failure or if something is missed by the primary magnets. But they're cheaper to install, but they only work as well as the operator takes care of them, because they have to be manually cleaned. So the question to ask is, how steel free do you need your crumb rubber to be? And you might need one or all of these different types of magnets in your plant. Looking at that a little bit more, crumb rubber that is 99% steel free, which sounds like a lot, but it's really maybe just a fuel quality material. It still has 20 pounds or 10 kilograms of steel in 1 ton, which is an awful lot. 99.9%, that's 1 kilogram of steel in 1 ton, and 99.95% still has half a kilogram of steel in 1 ton of crumb. So those numbers sound very, very clean, but you can't imagine that if you're going into any kind of consumer market, that consumers for playground or for mulch are going to be very accepting of half a kilogram of wire still in that product. So for consumer markets, you must be much cleaner than 99.99%. And even there, you still have 100 grams of steel and 1 ton of rubber. I mentioned earlier that fiber is a constant part of every fiber removal is a constant part of every tire recycling operation. It really can be the villain of tire processing in general. So what is all the fuss about fiber separation? Well, one thing to consider is that not all tires have fiber in them. Truck tires have very, very clean fiber. You can see a truck tire material on the left, or a mixed or passenger car tire material on the right. So one way to avoid a lot of the fiber separation is to simply run truck tires, and they have a small amount of fiber in them, but they're generally much, much cleaner. But anybody that is running the passenger car tires is going to be constantly removing fiber throughout the entire system, and really is going to have a lot of house cleaning related to keeping the fiber clean around the facility. And you might ask, what happened to all the crumb rubber? The fiber, as it's pulled out of there, it rolls up and becomes very bulky. So even though the fiber is not present by weight in a lot of the tire, it's only 5 to 7% of the weight of the tire. When you're done by volume, the fiber is actually a great deal of the volume that's removed from the facility, up to 50% of the volume after granulating. So you can see here, this is a fiber product in the box on the left, and these are a separated material. This is fiber, and this is passenger car material. And I'll call attention to the fact that this is US material, and we use white walls in the US, so you can see all the little white flecks. So this is not considered a dirty material, because the white walls are part of the tire itself. But anybody that's running generally US material will have white walls in it. And again, you can avoid the white walls by running truck tires. So cleaning up the crumb rubber is a constant challenge. Fiber separation is not achieved with a single machine. We use air filters and air systems. We use wind shear and elutrator machines that look like cyclones. We use orbital screeners and gravity table separators. But the message here is that you need to be doing fiber separation and fiber removal constantly throughout a high quality tire recycling system. So you're generally going to be removing fiber and collecting fiber at a minimum of 8 locations inside a 4-stage plant. And after the fiber is out, of course, you can't overlook the stones. Tires have sand, they have rocks, lead particles, brass, and other contaminants. Obviously, they can't be in the crumb rubber as well. So those high density contaminants are removed by the destoner that you saw earlier, which is a density separator. And those are used to produce a clean crumb. We all know that choosing quality equipment is very important, but there is no equipment that doesn't require maintenance of some kind. So part of having profitability and reliability in a tire recycling facility is going to be part of the maintenance. Within the system, the material handling systems, the air systems, of course, you'll need to be keeping the magnets and the nearby surfaces clean of wire. You'll have to be greasing the shaft bearings. You'll have to be keeping belts tracked on belt magnets and conveyors. You'll have to be checking splices on magnets and conveyors, maintaining safety guards, keeping the drive system clean and free of contamination, and checking all of these safety systems regularly. Because at the end of the day, what you really don't want is you don't want to have a multi-million-dollar investment in a tire recycling facility that gets shut down because of a $179 bearing that has failed at the most inopportune time. And it could have been prevented and done at a different time. So to repeat, maintenance is really no place for complacency, because you want to operate the machinery with less stress and within the manufacturer's guidelines. You want to achieve maximum production of all of your equipment. You want to produce higher quality materials and keep operating costs reduced. But I guess you don't have to if you maybe prefer catastrophic failures to routine maintenance, or you're indifferent to product quality, and I can assure you that your customers are not, or if the bottom line is of no concern, and I can't imagine we have anybody of that mindset here. And last but no means least is housekeeping and safety. The two things that we hear the most after hearing about an unfortunate accident or operator injury are lack of. The sentences start with the words lack of, and they sound like this. They sound like a lack of housekeeping contributed to a fire, or a lack of plant safety contributed to an operator injury. There's not a great deal to dwell on in regards to housekeeping and safety, other than it has to be a really first and foremost in your agenda every single day. You need an emergency plan. You need plant inspections. To put it simply, where does high quality rubber come from? It comes from a clean, safe, and well-maintained tire recycling facility. So what is the main process to produce quality? Well, it's a commitment. It's a commitment to installing quality machinery. It's a commitment to maintaining that machinery. And it's a commitment to housekeeping and daily tasks regarding that machinery. So whether you're operating a set of 5-ton rolls or 150 gram knives, if you ignore these components, you're certain to fail. So a question that comes up a lot is, why does it matter what size crumb I need? Well, the reason this is so important is that a properly designed system focuses on the output. For instance, if you have a customer that wants to buy 25 millimeter wire-free TDF, why would you look at a system that makes 0.6 millimeter product? So the questions that you should be asking are, what is the right equipment I can buy to achieve my exact business need? What type of input material does that machinery accept? And do I want to run truck tires only, or do I want to run the passenger and truck mix? You remember these pictures from earlier with the truck tires on the left and the passenger car material on the right. So you need to figure out if your customers need tire chips, or if they need fine powder, or if they need something in between the two. So looking at that a little bit more detail, you remember this diagram from earlier, stage 1, stage 2, stage 3, and stage 4. At the bottom, we have these different uses, and each of these is a different customer or a different type of customer that requires a different specification. Of course, most people know that the smaller you make the material results in more money for that crumb rubber. But it also costs you more money. It costs more money in the initial purchase. It costs more money in maintenance and in operation costs. And there's more product losses like the fiber removal, which is generally a waste product that goes to landfill. So really the first place to start when you're looking at figuring out what type of tire recycling facility you need is to start at the customer's requirement and work backwards. So this is your customer. Let's say your customer needs a 0.6 millimeter rubber. Maybe that's going into a asphalt paving application. Well, you're going to need a system with a cracker mill to do that. So the way we approach this is to start here on the bottom right with a customer's requirement. And we say, well, we need a cracker mill. And then the next step is to figure out what size equipment makes the product for that cracker mill, and work backwards and keep working backwards through those steps until you end up with an incoming tire feedstock that looks like your product. And of course, it might look more like this. Again, on the lower right, you have the customer's requirements, which is 1.5 tons an hour of a 0.6 millimeter product. It goes into the cracker mill, and we had 1.5 tons an hour here, but remember that's the output. So I told you earlier we have other products that are removed from the tire at every phase, including fiber and steel. So if you're getting 1.5 tons an hour out of a cracker mill, well, you're not putting in 1.5 tons an hour to get that out. You might need to put in, say, 1.55 tons an hour or something like that. So it's the same with the granulation stage. Maybe to get 1.55 tons an hour out of the granulation stage, that might look more like 1.7 tons an hour that has to come out of here of the grinding stage. And of course, we're pulling the steel out, so maybe that 1.7 tons an hour really becomes more like 2.5 tons an hour here in the shredding stage. So your incoming tire feedstock to get this 1.5 ton an hour out really has to look much higher, maybe more like 2.25 or 2.5 tons an hour to create your customer's requirement, which again is this 1.5 tons an hour of 0.6 millimeter product. So how do you know if a tire recycling plant is suitable for your needs? Presumably you're going to be looking at tire recycling plants from all different manufacturers. And of course, all manufacturers have nice advertising pictures with lots of pretty paint and good systems. But what you really need to do is go in there and look at the machinery itself. And you want to be asking yourself, are the feeding devices keeping motor load constant? So you want to be sure that there's not surges or gaps in the material. You can be looking, when you're there, you can be looking at the amperage of the motors. If the amperage is going up and down a lot, well, that's a sign that maybe there's a loss of efficiency and the system is not being fed properly. You want to be asking, are the material handling components conveying material without buildup or material loss? Are the fiber separation and dust collection effectively removing the fiber? Is destoning and the gravity separation effective? And most importantly, does the output material look clean without any fiber or debris? And you can, of course, see this just with your eyes. And we talked about housekeeping. All tire recycling facilities are going to have housekeeping as a constant part, but does the system keep housekeeping to a minimum, or does it really throw fiber and rubber everywhere? That can be a very, very big mess if the dust collection and fiber separation is not doing its job. You want to be sure that safety is part of the design, and you want to be sure that those peripheral components are properly matching the primary components so that they can all do their job properly. But most importantly, you need to be asking, does the system make a product that my customer wants to buy? And then last, you have a clean product now, but you can't forget packaging. We know today's market requires flexibility. So whether you package in a 10-kilogram bag or a 20-ton truck, you really need to consider what your client needs. For instance, we know that an asphalt contractor will not want a 10-kilogram bag. A tire manufacturer will not want 1-ton super sacks. So you need to be taking these into consideration and packaging it in the format that your customer needs. You need to be taking test samples regularly of this product and document the results. Beyond quality assurances for your customer, that helps you observe the machinery wear and monitor for a screen failure. And that concludes the presentation today. I'd like to thank you for your time. I think there's a Q&A session after this, and my contact information is here. You'd be welcome to reach out to me directly also after this presentation.
Thank you very much, Mike, for your presentation. As you said, we have now time for the Q&A session. We have received already a couple of questions. Let's start with this one. How can the material engineer engage in the tire recycling process? Can you hear me, Mike?
Yeah, yes, I can. I think the best way for the material quality engineer to be engaged in the process is to really focus on the customer's requirements and work on explaining that to the tire recycling equipment manufacturer. Those are really the most critical parts of figuring out which piece of machinery and which processes and components we're going to use, is understanding what the customer is looking for exactly. And again, that's not our customer, that's not the tire recycler, that's our customer's customer. So we're, as the manufacturer, we're generally not talking directly to the end user of these materials.
Thank you very much, Mike. Next question. How do you determine the electricity needs?
Can you repeat that?
How you defined the electricity needs?
The electricity needs are typically going to be determined by the machinery that's present. Really, we're going to have general specifications for each step of the process, and those electrical loads are just added together, and that will determine the total electrical load on the grid. If only a certain amount of grid power is available, then that might either limit the process or require mobile equipment or require some type of diesel generator.
Thank you, Mike. Next question. second. What are the minimum and maximum volumes per hour capacity for your systems?
Well, there's really there's no maximum to speak of. The functional maximum is not really a tons per hour number, but a function of how many tires can be collected in one place, and how limiting is the expense of the material or the machinery to achieve a certain task. At the other end, the minimum is something I think a lot of tire recyclers are challenged by, because it just takes a very significant piece of machinery, very heavy duty, very robust piece of machinery to process a tire. So it makes sense that a robust piece of machinery is going to need heavy duty components. It's going to be very heavy duty, and it's going to have a significant capacity. But to answer the question, generally it'll be in the neighborhood of 2 or 3 tons an hour is really the minimum that you need to be able to justify the cost of the machinery.
Thank you, Mike. A related question, is forward integration possible in this setup?
I'm not sure I understand what the question is asking.
Maybe Mr. Swain, if you could clarify what do you mean by this question? We would really appreciate that. Thank you. In the meantime, we can continue with the next question. Well, next question is related to prices. What is the minimum plant cost range? What if we can also integrate tire pyrolysis?
I think really in order to discuss things like prices, we probably need to ask somebody to reach out directly to a manufacturer and talk to them. We know that most machinery is quite expensive, but it's not very useful to speak in generalities without having specific ideas of what customers' needs are.
Of course. Next question. A person from South Africa is writing and asks if they have any plants installed there at the moment.
Yes, we sure do.
Great. Okay, as Mike said, you have already his contact details, so please free to reach him afterwards, and also myself. You're very welcome to send us any additional questions you may have. But I think at the moment we have shared all the questions we got. I'm just double checking, but I think we are done with this. I would like to thank you again, Mike, for your presentation, and thank you everybody for taking part in this session. We would very much appreciate if you could help us keep our service relevant by giving us your feedback. So we will send you a form with a few questions very soon. And also, as I said before, the presentation that was shown during the conference. If you want to learn more about these topics, please kindly note that we are issuing a tire recycling related newsletter once a month. And also in our Weibold Academy section, you will find a wide variety of articles that highlight the different aspects of managing this business. If you have any questions related to the webinar session or our consulting services, please do not hesitate to contact us directly. We are looking forward to seeing you at our future webinars. Thank you again, Mike, and thank you everybody, and have a nice day.
Thank you, Augustina, you as well.
Thanks a lot. Bye-bye.
Bye.